Hi everyone, in this video we'll take some questions about the continuity of a function that contains absolute value functions. So this is the first part in our example, and we have the function, the piecewise function here, and the question is the function of x given continuous at x equals to 1? This is the question. So as you know, 1 is a common between the two intervals, and to check the continuity around x equals 1, this means you have to see or to check if limit of x when x goes to 1 from right equals limit of x when x goes to 1 from left equals the image of 1 under the function f. But before we start this check, you have to define a function again, because we have an absolute value function, so you have to get rid of the notation of absolute value. So the function is 1 absolute value of 1 over x minus 4. This is the absolute value that is in our function, and this is equals to absolute value of 1 divided by absolute value of x minus 4, and absolute value of 1 is 1 divided by x minus 4. Now the 0 of the inside function is x equals to 4. Now this is the number line we have, and we have 4 here. Now you have to check if the function is, if the inside function x minus 4 is positive or negative in the interval when x greater than 4 and the interval when x less than 4. So you have to take a point or a value of x which is greater than 4, let's say 6, and when you substitute x in x minus 4, you will get 2, which is a positive number, so we will get the same function in this interval. So we have 1 over x minus 4 when x greater than 4. Now for the other interval when x less than 4, again you have to take x less than 4, let's say 0, and you have to substitute 0 in the function x minus 4. You will get 0 minus 4, which is negative 4. So the function x minus 4 is negative in this interval, so you have to reverse the sign of the function, and you will get 1 over 4 minus x. So the original function here, we have the interval from 0 to 1, from 0 to 1, which is included in the interval when x less than 4. So the function will be f of x equals to 1 over 4 minus x minus 1 over 3 when 0 less than x less than 1, and negative 1 over 3 when x greater than or equals to 1 less than 5. Now as you know, when we have x less than 1, this means 1 from left, and x greater than or equal to 1 means 1 from right. Now you have to check the continuity around x equals 1, and you have to find the limit when x goes to 1 from right and left of x equals to 1. So firstly, limit f of x when x goes to 1 from left equals limit the function here, sorry, the function is divided by 1 minus x also, so we have 1 divided by 4 minus x minus 1 over 3 quantity divided by 1 minus x when x goes to 1 from left. By direct substitution of 1 in the inside function, you will get 0 over 0. So you have to do something to find the limit, And here we have two rational expressions, and you have to make the denominators the same because we have unlike denominators. So you have to multiply the first one by 3 and the second one by 4 minus x to get like denominators. So this is equals to limit of 3 minus 4 minus x divided by 3 multiplied by 4 minus x, all quantity divided by 1 minus x when x goes to 1 from left. Here you can put these denominators beside each other, so you will get limit of, now 3 minus 4 is negative 1, and we have negative x, which is a plus x, divided by 3 times 4 minus x multiplied by 1 minus x when x goes to 1 from left. Now you can write negative 1 plus x as x minus 1. We have here a common denominator or a common expression between numerator and denominator, so you can cancel 1 minus x with x minus 1 and you'll get negative 1. Then you have to substitute 1 in the function inside and you will get negative 1 over 3 multiplied by 4 minus 1, which is negative 1 over 3 times 3, which is 9. So the limit of the function when x goes to 1 from left is negative 1 over 9. Now you have to find limit f of x when x goes to 1 from right. 1 from right from here, and the function is negative 1 over 3. Now as you see, the limits are different. So the conclusion is limit f of x when x goes to 1 from right not equals to limit f of x when x goes to 1 from left. And this leads to say that f of x is discontinuous or not continuous at x equals to 1. In part B, again, you have to check if the given function is continuous at x equals 2. But first you have to redefine the function without an absolute value notation. And we have a rule here. If we have absolute value of m less than or equals to a, this is equivalent to say that m is greater than or equals to negative a less than or equals to a. So in the interval, or in the first interval, we have absolute value of x plus 1 less than or equals to 3. Now you have to use this rule and you have to rewrite. This is the quantity inside the absolute value, which is m in our rule, which is x plus 1 in our question. So you have to write it as x plus 1 greater than or equals to negative 3 less than or equals to 3. Then you have to subtract 1 from all sides and you will get x greater than or equals to negative 3 minus 1, negative 4, less than or equals to 3 minus 1, which is 2. So you can rewrite the function again as f of x equals to x squared minus 4 divided by x minus 2 when x greater than or equals to negative 4, less than or equals to 2, and in the second piece we have x plus 3 when x greater than 2 and less than or equals to 5. Now here we have x less than 2, less than or equals, and this means a from left. So here we have 2 from left, and here we have x greater than 2, which means A from right. So here we have 2 from right. In our question, you have to check the continuity around x equals 2. So you have to check if these limits are equal. So firstly, I will start with limit f of x when x goes to 2 from left. This function will be working this limit, and it will be limit of x squared minus 4 divided by x minus 2 when x goes to 2 from left. If you use direct substitution and plug in the value of x equals 2 in the inside function, you will get 0 over 0, which means you have to factor the function in numerator. And this is a difference between two squares because we can write 4 as 2 squared. So it will be x plus 2 multiplied by x minus 2, all the quantity divided by x minus 2 when x goes to 2 from left. Then you have to eliminate the common between the numerator and denominator, and you will get x plus 2 as the simplified function. Now you have to replace or plug in x equals 2 in the given function, and this will give us 2 plus 2, which is equals to 4. So this is the limit from right of 2. Then you have to find limit f of x when x goes to 2 from right, 2 from right from here. So you have to use this function, and this will be limit of x plus 3 when x goes to 2 from right. Plug in 2 in the side function, you will get 2 plus 3, which is 5. Again, as in the first part, the two limits are not equal. Limit f of x when x goes to 2 from right not equals to limit f of x when x goes to 2 from left, which means that f of x is discontinuous at x equals 2. So this is the idea of continuity of a piecewise function. You have to check that the limit of x to the right of a given value equals to limit f of x when x goes to the left of the given value, and you have to check if they are equal or not, and that's it. In part C, the case is different because we don't have a piecewise function. Okay, we have an absolute value, but no need to redefine the function without absolute value notation. Here's the question is find the values of x at which f of x is not continuous. So this equation the same as find the domain. Find the domain or find the excluded values for the given function. So first you have to check the domain, and you have to deal with denominator, and you have to put denominator equal 0 to know where is the function is not continuous. So the idea is absolute value of x squared minus 2x equal to 0 only. This is the idea. And if you have absolute value of something equal 0, this means the quantity inside the absolute value is equal to 0. So here we have x squared minus 2x equal to 0. Now you have to take out the greatest common factor between the two terms. So we have x multiplied by x minus 2 equals 0. By the 0 property, this means x equal 0 or x equals 2. So f of x is discontinuous at x equal 0 and x equals 2. And that's it. Thank you.